All right, this one might be kind of longer. It's just the actual notes, but I wanted to make sure you got to see what they were. So, polynomials, we're going to use them to find area and perimeter. What perimeter is the distance around something. Think of it like a fence around a yard. That's perimeter. The area is kind of the amount of space. I'm just going to write the inside. Hopefully that helps you remember. So let me show you this. Perimeter would be how far around this box. Like we could measure that, right? You could take a ruler and measure all 4 sides and add them up. That's perimeter. Area is different. It would be how much space is in this box. Okay, so hopefully that helps you see the difference between perimeter and area. Perimeter, distance around it. Area, inside. Okay? In order to find perimeter, you're going to just add the expressions on the sides of your shape. Okay? And that works forever and ever for perimeter. For area, you're going to multiply using a formula. All right? So let's do a few examples. Remember, you can pause this at any time to help you really understand. For our first example, it says to find the perimeter of the triangle. Perimeter is the distance around it. And in order to find the distance around, all you do is add them up. I got that one. I got that one. And I got that one. So now I have all of the sides. This is an algebraic expression, and we need to combine like terms. Remember, when we combine like terms, we look for the ones that have the exact same variable part. This one has x squared, so we're going to look through for another term with x squared. Hey, there's one. And circle that also. This one has x, but it's not squared, so this does not combine. It's its own different term, and plus 5 also has no friends. Now we're going to combine like terms. So we have 2 x squareds and 2 more x squareds. 2 plus 2 is 4 x squared. Nothing to combine 4x with, and nothing to combine 5 with. So the expression that represents the perimeter is 4x squared plus 4x plus 5. All right, let's look at the next one. Again, we want to find the perimeter of this. And perimeter is the distance around. Okay? But we only have one side given to us. And that's okay because it tells us it's a square. And squares, all 4 sides are congruent. They are all the same. So on all sides of this square, I can write the same expression. And in order to find the perimeter, we need to add up all of those sides. That's 1, 2, 3, 4. Okay. Usually when you put something into a formula, you kind of keep it in parentheses. And when you are adding polynomials, you remove the parentheses quickly, so that's kind of why I didn't. All right, there is another way to do this, but I'm not going to show you that part now. And now we're going to go through and find the like terms. So we have s squared, s squared, s squared, s squared. And then we have our s's, And now we're going to combine like terms. 1, 2, 3, 4 s squareds. 10, 20, 30, 40 s's. And that expression represents the perimeter of that square. All right, let's do the next one. The next one says to express the perimeter of the triangle. Perimeter is the distance around. And in order to find perimeter, we need to add the sides. Okay, I used all the sides. We need to combine like terms. So we have 3x. Do we have any more x's? Yes. Yes. And then we need to find our constants. These all go together. Combining like terms, 3 plus 6 is 9, plus 8. 9 plus 8 is 17x. 1 plus 2 is 3, minus 2 is 1. This expression represents the perimeter of this triangle. Part B says to find the perimeter when x is 1, 2, and 3.4. So you may remember this from earlier. We would make a chart kind of like this. We have x, our expression. We used to do it with y, but this time we're just going to find the perimeter. Okay. We're going to try it with x is 1, 2, and 3.4. And all we're going to do is substitute into our expression. Everywhere there was an x, we're now going to change it to the number that they gave us. And we can do that in our head, or I'm just going to use Desmos real quick, if that's how you would do it. So we have 17 times 1 plus 1 is 18. I'm going to replace the 1 now with a 2 for this one. So that's 35. And lastly, I'm going to replace it with 3.4. Okay. So the perimeter of this triangle, if x is 1, is 18. The perimeter of this triangle, if x is 2, is 35. The perimeter, if x is 3.4, is 58.8. Okay? And that's perimeter. Let's look at the next page. Okay. Now we're kind of changing gears because now it wants us to find the area. Remember, the area represents the space inside the shape. And when you do area, you're using a formula, and it's usually a multiplication formula. All right, so this is a rectangle, and the formula for the area of a rectangle is length times width. So it's going to be 10y plus 2 times 7y minus 9. Length times width. Okay? The rule for multiplying polynomials, the way we've done this in class, is we've made a box. I hope that might helps you remember. And then we multiply. 7 times 10 is 70. Y times y is y squared. 7 times 2 is 14. Y, and there's no y there, so we just have 1. Negative 9 times 10 is negative 90, and there's only a 1y. Negative 9 times 2 is negative 18. Pulling everything out of the boxes, checking through to combine like terms. We have y squareds, plane y's, and constants. So we're left with, I'm going to write it over here, 70y squared. Combine those. It's going to be negative. 90 minus 10 is 80, 76y. And then the 18 had no friends. So the area of this rectangle, represented by an expression, would be this. All right, let's try one more. Use the following to find the area. Whoa, it says area of a rectangle, but this is a square. Or I mean a triangle. We want to figure out how much space is in there. And actually, we're not going to do that problem or the other problems because I think that's probably plenty for now. If you want to see the other problems, I will show you those later. Have a fabulous day.